Now, one other example with just one variable that falls in the same pattern is when we have a pattern where instead of powers of x squared, then x, and then no x at all, we're going to have x to the fourth, then an x squared, then no x at all. So we'll look at the pattern a x to the fourth plus b x squared plus c. And we'll just look at a concrete example. We're going to use the same method whenever we have a pattern in our powers for a trinomial of 2, 1, 0, that's what we had with the ax squared plus bx plus c, or of 4, 2, 0, we can go ahead and use the same method. We can use that product sum table. So let's take a look at 6 y to the fourth plus 7y squared minus 20. We've got the pattern 4, 2, nothing. And what we really, the reason this will work is that we really have here a y squared squared. So we have a thing squared, and then we have just our thing, which is a y squared, and so on. We'll take our product sum table, right here. Our product is negative 20 times 6, which is going to be negative 120. And the sum we're looking for is a 7, positive 7. This one is not too hard to figure out. We can start with a 12 times a negative 10. That one's one that probably leaps out since there's a 0 on the end. And that will add to 2. So they're a little too close to each other. We need to spread out a little bit. At this point, it may or may not be helpful to look at a factor tree. If we took 120 off to the side and did 12 and 10, we'd have 4, which is 2 times 2, and the 3. And the 10 is going to be a 2 times a 5. So these are the factors we have to work with. Let me zoom in on that a little bit. Make it a little more readable. Yep, wrong button. There we go. That's a 5 on the end. Okay. We could try a 15 times an 8 and see what that does for us. One of them has to be negative, so that's looking really good. Make the 8 negative. 15 times a negative 8. If you check that, it should come out to be 120, and it will. And they add to a positive 7, so we're good. These are the numbers we want to use. We rename the second term. So we've got 6y to the fourth plus 7y squared minus 20, and we rename that as 15y squared minus 8y squared. And then we have our 6y to the fourth, and we subtract 20. We factor by grouping. We have to pay attention to the sign. Whenever there's a negative sign, you have a little extra paying attention to do. Out of this, I see a 3 and I see a y squared, leaving me with a 2y squared, and I have to be a little careful. 3 goes into 15, leaving me with 5. And I don't have a y squared left because I pulled it out. I see a negative 4 here. So I'll take out a negative 4 and I'll have a 2y squared. And 20 divided by 4 is 5. But now that's plus 5 because I pulled out a negative 4. Now I go and look, and I see, aha, yes, the insides of the parentheses are exactly identical, so this problem's looking good. I pull out the 2y squared plus 5, and I'm left with 3y squared minus 4. These are prime polynomials. There's no further factoring to do with them at this point in your life.